Kia ora, I'm Robert Amor, a Professor of Computer Science at the University of Auckland, and in association with my colleague Johannes Dimyadi, I'd like to talk to you about computable planning rules for automating urban land development. This is part of a larger project that's been ongoing for around a decade, looking at how we transform codes and standards in New Zealand into a computable form. So with the use of BIM and other tools, we're able to automate the processing and checking of our designs against the relevant codes and standards in the country. So in the project here, we're looking at land development, which obviously is subject to compliance with resource consent, planning rules specific to districts and regions under the Resource Management Act. So the main information that we're seeing here are the legal properties and topology of the land that we're looking at. This is data that is held by LINS and is openly available and accessible for us to perform analyses and calculations with. All of the planning rules which are available in each of the districts, and these are written for human interpretation and often quite large in terms of what needs to be assessed, and also looking at financial models, so the cost versus benefits of the planned development or redevelopment on the land that we're looking at. So some of the issues that we know about is just the large amount of information which exists in the rules, which are written for humans and interpreted by humans, but are not easily accessible to computerized systems, or not made available for computerized systems in a published form. So what would be really nice is if all of our codes and standards and planning rules were available in a computable form as well as a human interpretable form, so that any tool would be able to take that information and do calculations on the latest version of our codes and planning rules. Where we do have calculations available to us inside these rules and codes and standards, then often what this means is someone has to take information off the designs that they get, plans that come through in 2D PDFs, extract the relevant information, put it into some spreadsheet or calculation system, and do some checks on that data. And obviously for a human to go through designs, pulling out data and transferring it into another system, this is a potential source of error, often a source of error as things get transferred across. And it's a very time-consuming process, having to go through all of that documentation and identify the correct information, and needs to be checked and validated very closely to ensure that what comes through is giving the right results. But where people have looked at computerizing these systems, creating calculations in spreadsheets or in other software systems, the approach they tend to take is to hard code the rules and regulations and the calculations into their tool, so it can perform the calculation that has been hard coded. But the issue that we have with this is that as the rules or code standards change, which they do quite frequently, then someone has to ensure that these systems which have hard-coded rules are updated. And so if there are many pieces of software out there, there are many people who have to go through that software and ensure they're always up to date and consistent with the changed regulations that we have. And this again is a source of error, that the systems are not responsive to the changes that we have in the law. So the question that we're looking at here is, to what extent can the planning rules be computerized to support automated compliance audit? And the case study that we're looking at is based on the Auckland Unitary Plan and a land development redevelopment project in Auckland, going from an existing single dwelling to a high density terraced housing zone. And so looking at what is possible on the land redevelopment and what the financial potential is of that redevelopment. But the process that we go through to try and have a computerized version, extraction of the knowledge from the planning rules, is preparation of the documents, so we get it in the form that we can work with, extracting the knowledge out of those documents through an expert's interpretation of them, and then formally encoding those in a form that can be processed by a computer. So the first part of of this process. We have documents which are typically in a PDF format, and we need to get the text out of them so that it can be processed by humans or by computers to get the rules that we need out of those. Just having a huge set of text is not particularly useful. We need to have some of the structure which is in the document. So we need to know the different clauses and subclauses and the structure which is inside the documents that we have, so we can process them and handle them in a particular way, preserving the hierarchy and the links between the rules which are in there. So we have a format, open format called legal.ml, which allows us to represent the structure of legal documents, and this is the form that we have been putting these documents into. Once we have the documents in this form, then we can work with human experts to step through each of the clauses in there and look at how they would be interpreted and what a computable representation of those rules would be. And so the human will go through clause by clause, identifying what the appropriate rule or calculation should be, and putting this into a domain-specific language format. And here is what you can see is a spreadsheet format, which gives a simple way for the expert to describe what the rule is and what the conditions are and what the calculations are from that rule. From the spreadsheet format, we go through a quality assurance process. So we have another expert looking at the rules to make sure that there's consistency in the way they're approached, and there is agreement between the experts on the interpretation of these rules. And then once that has been achieved, then we can automatically generate a format which can be used by computers to do the calculations. And here what we use is a format called legal Ruleml, which is an extension of Ruleml, which is set up for the legal profession, and again gives us a way of describing what the calculations are in a way that a computer can interpret them and apply them automatically. When we have all of the codes computerized, that gives us all of the calculations which need to be done. It doesn't say anything about the order that need to be applied or how they're typically interpreted in the manner that they should be interpreted. And so what we have is a process workflow, which gives us a way of specifying how a human should go through, how a human would go through and do these calculations. And so we can ensure that the computer goes through the same process, performs the same calculations, and performs the same calculations in the same order. So this gives us some certainty that the results which are coming out are going to be the same as a human expert would provide, because we're following the same process. We're getting the same data from the BIM models or from LINs or from whatever source of information we need, and we're getting the same rules from the planning regulations and in their interpretive form that we can apply to the calculations that we're doing. So an example that we have for this land redevelopment, this is a tool called Ackerland, which has been developed by CAS Limited using this approach. You can see inside the tool, we make queries of the LINs data, which is openly available. And so for a particular lot, we can pull up all of the information, the zoning that we have, what can be done with this land. From this, we can do a range of calculations. And so we can identify the clearances which are needed, the percentage building coverage that's allowed, all of these parameters which can be calculated from the land that we have. It's a human-driven approach, so we allow humans to enter parameters so they can say what they're interested, how many stories they might want, and from that we can calculate how many lots there might be on the land and other parameters from that. We can also look at the financial aspects of it and provide information about what we expect from financing rates and costs, and from that we can get an idea of what the likely a return is going to be. And you can see in this case study that it's economically viable to build what we're looking to build on this. So in conclusion, what we can see is that planning rules can be computerized through use of human experts. We can identify an appropriate way of representing planning rules. Through the human guided workflow, we can give confidence that the results which have been calculated are the same in the order that a human would approach them. This is obviously much faster to do. So with the computer and human interaction, entering various parameters takes about 10 minutes to get to the point where we have a report about the land development, versus something like 2 days to do the same thing when we do it manually. And the data that we get out of this is within 5% of what a human would do as they go through this, 5% on the conservative side. So thank you for your attention. Happy to take any questions at this point. And if you'd like to talk to CAS Limited, then Johannes Dimyadi's information is there for you to have a look at.
Hello, everyone.